we're adding also the SVG jQuery plugin to the system. And then, the thing I have to show, where do we use SVG? Well, this is just one interface. If you click on here, okay, well, more or less, the colors aren't great, but so you get actually a tree visualization of your event. This is an event of Shakespeare, Othello. So the main root node is here. You got a timeline of all your events in the system, and it basically animates. So you can focus on the different parts of the system. You can do a fetch more. These are the only events which are in my test database, so we're actually focusing just on this one. So this is created with SVG, just rendering, and then also doing just Ajax updates, not re-rendering your entire system on the fly, otherwise you cannot get these nice visual animations. But there is a problem. Yeah, maybe I'll first show here. You can. So actually what it shows is that you have the event, and this is actually the resource planning tool. Your calendar gives you the main overview of all the events in the system, how they are related, gives you basic things. Here they can do the resource planning, because they can say, well, for the event Othello 1, it will be in this room. We need from Theatertechnics, this is in Dutch, sorry. We need Frank, we need a big PA, we need a small light set, we need a wireless microphone, and so on, and you get the entire planning. The thing is that the things are, why do we have trees? Well, you will have, if you have one performance of Othello, you will probably have them over a long distance of time, and so they're able to plan this visually like this. So what was the issue here? They wanted animations, no question about it. Needed animations, it had to go nicely from one to the other part. So we had to animate SVG. Animating SVG is nice. Adding new content to your SVG, because you saw when I was clicking up and forward, new nodes were added, but you always have these lines, and they were very picky on, no, the lines should always be under the date. It's very hard to see. But the lines should always go, where is my mouse? Lines should always go under here, and everything like that. So, so you had a bit of a challenge. Dynamic loading of SVG content, it's possible, but SVG follows the painter's algorithm. Just go from the top to bottom, and your Z index in your web page actually just goes up. So the last thing on the bottom of your HTML source page, SVG source page, it will actually contain, will be the highest one, the highest ranked. So basically you go down, your Z index goes up in your SVG. So what is already in the jQuery-SVG plugin, this is also not our work, there's a plugin created by somebody else, a pure jQuery-SVG plugin. We created wrappers for that, for the Seaside part. You're able to load new content in your SVG canvas or add content at the end. So we're stuck. So what we had to add is to add content to an existing SVG element. Why? You were able to control your Z index if you just make artificial groups, and you know, well, lines always have to go under nodes, so you put all your lines on top, nodes in the bottom. And that's something we added. Unfortunately, not yet present on Squeak source, because we're not sure yet. Either we have to put it into the Smalltalk wrapper, or we have to just give it as a patch to the JavaScript person of SVG jQuery. So, but this will soon be released as well. And then the nicest part and the most technical challenging for us was the use of object-oriented databases. We really wanted to keep with object-oriented databases in the system. We've been using Glorp as well for our part, so everything, actually every operation every user does in the entire system, up to the undo, even the undo, it actually logged. Those logs are put into a Glorp database. But for all the rest, the model is particularly complex, has a lot of pointers back and forward, and we really didn't want the hassle of having to map it to a relational database system. And on top of that, I think it's nicer to work this way. So we actually started out using Magma. Magma is a great system. Magma has indexed collections, has domatic indexes, has nested transactions. That's really cool if you want to be able to write your database operations in a normal way without having to think too much. And it has a write barrier. Now, what is a write barrier? For those who don't know, I will explain a little bit later on. Unfortunately, as I will show, the performance of Magma didn't really fit our needs. So we ran into a performance problem there, and we decided to move on to goods. As you see, in goods, you're basically on your own. No indexed collections, no nested transactions. There is a write barrier support. It wasn't working, and there was no implementation, really, a full implementation of a manual write barrier. So we actually added that. And then, I see people of Gemstone looking, so if I make a mistake, you're probably going to hit me afterwards. Because Gemstone is pretty new. We started about that like 1 month ago, because also goods wasn't really up to our needs, and we had to scale further. So we're reporting the entire system to Gemstone. It's almost working right now. It has indexed collections. It doesn't have nested transactions, right? It has a write barrier, although you don't really need a write barrier. Well, it's completely transparent, so probably it has one. That's why I put a little star there. So our solution, because we didn't want to get tied to Gemstone either, we want to run on multiple databases all the time. So we wanted to keep compatible running into an open source system, any database. So we created a general database access layer, common database access object terminology, which actually basically abstracts from all the databases. And without changing anything in our application, by just changing this original database access layer, which we designed when we thought we were going to use Magma for forever, we're able to actually just continue using that and just keeping the changes local to that database access layer. So we have one specialization for Magma, one for goods, one for Gemstone. And there we put everything in. So what's the write barrier for people who are unaware about object-oriented databases? Well, you have your database here on the right. You have your Smalltalk runtime. So you connect to your database and you load your objects. Your objects are in memory, and your database layer just keeps track of which objects are actually loaded. So that in case you change them and you want to do a commit, it just goes through all these objects and will write the changes to the database. The problem is, with goods, as a general solution, so without manual write barrier, goods has to go through all the objects to see which one has changed, and then just send the change to the database. If you have a manual write barrier, you have a write buffer, and you actually have to manually put the objects you changed into the write buffer. You have to manually do that. Our database access object layer actually takes care of that, so it works. Why do I want that? What do you have to do for a manual write barrier? You have to track changes to your database objects. And you have to do that yourself. Every collection, everything, you always have to say, I was changed. So you go through all your objects. You have to use customized collection classes. That was missing in goods as well. So we were adding a lot of these custom collection classes, because if the collection object changes, you add something, you have to send the update. And then goods already uses this write buffer. So the support was there. So why? Why? Well, take a look at this. I tried to make some benchmarks, which actually give us representative behavior of what we were seeing inside our application. This one is actually not so important. It just measures, it does 1,000 commits. I did 1,000 commits on the same machine, and these are the results. Magma in blue, goods with the automatic write barrier in red, goods with manual write barrier in the yellow, small, and then Gemstone in green. So it's not really useful. You're never doing 1,000 commits one after the other. You're never doing that. So there's no problem, but it just gives you a little bit of a background here. Then, something which sometimes happens, you do a commit of a large collection of objects, of a large set of objects. Okay? We just loaded 100,000 objects into the system, and we launched one commit. Magma, more or less the same performance. Goods, well, but these are seconds, by the way, on the left-hand side. So if you do that, it really takes a long time. Goods with the manual write barrier was actually a lot longer, because the manual write barrier implementation just takes a lot longer to execute. So if you're doing 100,000 objects, it will always send this change and voila. Gemstone is invisible, so lower is better in this case. And then this one is actually the most representative one. We have a lot of objects loaded into the memory, as I will show you why we need that later on. What if you make one change, one single object you change in your system, and then you launch the commit, which is something you often do. There's lots of objects loaded, one commit. Magma, gave me for 100,000 loaded objects. Now these were pretty simple objects. You have to take account that the performance also suffers the more instance variables you have in your objects and the more dependencies and so on. But Magma gave me 6 seconds, so the user actually was hitting add new event in the calendar, and it took 6 seconds to load. That was not possible. Goods with the without the manual write barrier is as performant. Goods with manual write barrier is way fast. So it's invisible here because, of course, we just have the one object and the one object to send, and we did it manually. So this is pretty cool. We were very happy with that. Gemstone actually has exactly the same performance as the previous slide where we did a commit of 100,000 objects. So which is also very fast. So our candidates for if people want to keep in the open source world, we were sticking with goods, but we're moving to Gemstone. Now why? Well, another benchmark I cannot really show you, but this is the resource planning tool, and you're able to add resources from this place. So you see it as a pop-up window, and they're able to search through resources. So I just hit enter here, and I get a list of all my resources. This is just our test database, which contains about 30 different resources. Customer needs about 5,000 different resources. And the resource is a complex object because it has a cost model associated to it. It has lots of data points. So it's pretty complex, and it represents about the 100,000 loaded objects I was doing in the test. Loading that takes about 20 seconds using goods, because it has to create these wrapper classes coming over from the goods database. So when we started this interface, the user has to wait 20 seconds for the first time. So if he opens it the first time, you have to wait 30 seconds before getting it. Not acceptable, unfortunately. So we have to move to goods. So, to Gemstone. And with Gemstone, this worked, well, almost instantaneous, right? I cannot say anything else. The thing is that what we are trying to do is, if we keep with goods, for the goods solution, is that we will actually do a load in the beginning of the application, so things are loaded, or we do something else. But well, if anybody has any experience there, I would be happy to talk afterwards. I'll keep this closed. Go here. So, as I was saying, well, yeah, that was the thing. Then, our story of Gemstone just, it was all positive until now. Until the moment we started to work with these transactions and our concurrent users made changes. So, top user opens the calendar, bottom user opens the calendar, so there's two users using the system at the same time. The bottom user changes one of the objects, changes an event name. The commit happens, so the database is committed. The other user changes the same name. Problem. Cannot have that. We have to notify the user. Yeah. You cannot see it, but there is a little notification there. So the change doesn't propagate, so we capture that, and actually using our abstraction layer in goods, we were just able to capture that as a transaction conflict. But in Gemstone, so conceptually for us as well, the entire application is completely a transaction conflict. Problem is, in goods, we were able to create a database session per Seaside session. Gemstone, or Glass, the entire Seaside plus Gemstone integration, has actually what I could call a single database session. If I'm cursing against object-oriented database terminology, please tell me afterwards. So the problem there is that we didn't have different sessions. The problem is that when you have different sessions with goods, the thing was that whenever you did a new change, it was able to detect this. No, somebody else. The object just changed in the database, so it's a transaction conflict. Simple to capture. Another thing is that, well, actually all web frameworks which integrate with an object-oriented database or with a database in general, they do it this way. The transaction boundary is the request, start and end of the request. That's cool, but we weren't really relying